Good morning to all. This is Dogra, Associate Professor, Ben College. We will start with the data structure subject, and the topic that I am going to discuss is that is stacks. Now, let us look at the various topics that I will start with. Subtopic, that is what is stack, the definition of stack, the ADT, its application, and how it is implemented in C. Now, we will discuss one by one. Now, looking at the definition of stack, what the stack is. We all know that it is a formation of rather a plates. If we look at the diagram here, it stores a set of elements in a particular order. So, whatever the elements you can see over here, now elements here are the plates that are laying on one another, and you can see that it forms a stack. Now, looking at the basic principle, it is last in and first out. That is, whatever you keep last, that will be deleted first. You have to pick this disk first, and the disk which was placed earlier at the start will be the last one to be picked. So, that is why we call it as the last in and first out data structure. Now, these are the examples. In daily life you may see some other examples also. We can see later on what are the various applications of stack also. Now, here the formation of the stack that we look into, that will be something like this. Let us say that we have a bucket type structure, you can call it a array also, and if it is used to store the elements, and the elements, the formation of the elements has to be just like a stack. So, what I defined earlier was that whatever you insert at the first instance will be picked out last. So, here if we start with the first element as A, we have got a top, an indicator over here. This is a pointer or index that will represent the very first element on the stack. So, we get A over here and our top represents A. So, this is the top position of the stack. So, when the arrival of B is there, we will find that the data structure, in this data structure, top will be incremented by one position, it will jump to the next location, and we will get another element over the top of A, that is B. Now, our top points to the element B, we do not know what the element is below B. So, there is only one index in the stack that will let us know that which is the topmost element on the stack. So, this continues, and we can find that the insertion of the elements C and D will take the top one position over. So, the increment of top is there, and we can add the elements. So, we can add E also here, as you see in the diagram, and when you delete this E, you can find that top has been decremented. So, this is a simple logic we use in daily life, that formation of stack is just the collection of elements, so that we can pick the elements in such a way that last in is taken out first, and that is what the stack is. Now, let us look further about the applications. You can see in real life the pile of books, you study, you have a rack in your house, generally you place the books one over the other. So, that forms a stack. The plate of trays that we have already seen, and some more application related to the computer science. So, that are more relevant to us now. The first one is program execution stack, that how the program is executed. We will find that in the execution of the program, we do have some different subroutines. How these subroutines are executed, how the program control is distributed and it is given to some other function. Now, a stack plays an important role over here. We can find out the same in evaluation of expressions also. We will look into and find that how the infix expression is converted to postfix form, that will make use of stack, and some other programming examples too. So, this will come later on. First, we start with the basic structure, a finite ordered list with 0 or more elements. So, these are the objects. You can see that we have a stack, we have some elements in the stack, the maximum stack size has to be given, because if we are using an array to form a stack, we have to define the size of the array. That is the maximum size, the maximum number of elements that a stack can store. So, these functions, like the first one is to create the stack. We have to form a stack with some size which is mentioned over here. So, creation of a empty stack whose maximum size is max stack size. So, this value can be 9, this can be 90, this can be 100, this depend upon the user who is going to form the stack. Now, here you will find some condition, some functions that will be used, like the first one very important when we insert the elements, that is to check whether the stack is full or not. Because if I was talking about the limit and the allocation of memory being done to the array, that is a limited one. Whenever you want to store something, there should be space for the elements, and if the stack is already full, you cannot go and store some any other elements in it. So, we have to check that whether the stack is full or not. So, the simple condition, that is the number of elements in the stack, if it is equal to the maximum stack size. Let us say that we have declared the total size as 7. Now, we cannot store the elements more than 7. So, it is basically to check whether that upper limit has been arrived or not. If it has been arrived, then we have to return true. True means the stack is full, you cannot make any more insertions, else it is to be passed as false, that still some space is there where the elements can be inserted. We can see a very another function in the stack. We do have only two main functions, one is push, another is pop. Push is to add the element, to put the element on the stack, and pop is to get rid of the topmost element. So, the element is deleted, that is the topmost element. So, while pushing the element, as I told you that we need to check, we have just seen the function, this function in the last slide, we will check that whether the stack is full or not. If stack is full, you have to simply return the message, otherwise insert item into top of the stack and return. You have to add the element and then return, then there will be a new stack given to you, returned to you to the main function. Empty, of course, a very important function that is used, because whenever you want to pop something, pop the element, you cannot make the pop operation for the empty stacks. Stack has to have some at least single element to keep the pop operation or to give a success to the pop operation, otherwise it will return simple that element cannot be returned or element cannot be popped, because the stack is empty. And to check this, I can check this function, write the condition that if stack is equal to create as, this is the one function we have used before, if the status is very much same while we have created the stack, it means we have not added the element yet. So, it is true, the stack is empty, I cannot make the pop operation. But if it is false, of course, the pop operation can be done and it will return the topmost element of the stack. So, if it is empty, simply go back, no pop operation possible, else remove and return the item on the top of the stack. If you have at least a single element, your topmost element will be returned and that will be a pop operation of the stack. So, we have seen the two operations, push and pop. Push uses is empty, push uses is stack full, and pop uses is stack empty or not. So, these are the four main functions that can be used to implement the stack operation, to create the data structure which can be called as a stack. Array based implementation, like if you want to use a fixed a static allocation, then you have to use the array for that. Arrays, of course, you have to declare it, a fixed size will be declared and that memory will be allocated and that can be used as a stack. So, allocate an array of some size, you have to define the size before, maximum n elements in the stack. So, I can put that value in, it can be, as I told you, 7, it can be 15, any value that you want to add. So, this is the total number of elements that can be stored. Bottom of the stack element stored at index 0. We know in C++ our array starts from the index 0. So, what we need to do is that the first element will go to the first position, that is 0, index 0. The last index in the array is the top. So, as we go on adding the elements, pushing the elements, the top will be incremented and the topmost element will be the last, that is the last index, that will give you the topmost element. Now, increment top when one element is pushed, decrement after pop. So, we can look at the two basic operations. One is you increment the pop if you want to push, you decrement the pop when you want to delete or pop the elements. So, these two functions we can look at the algorithms also. The implementation part, to create a stack, now you can define that what your elements will be, what is the structure of the elements, what you are going to store. To make it very simple, I can say that there is a one key value if that is of data type integer. You can add some other fields also. Now, this structure variable has been declared and the definition for the stack exists over here. Now, this is the definition of a stack with a maximum size given here. So, whatever stack size 100 has been defined over here, you will get the array that will contain 100 locations. So, I can have maximum 100 number of elements in the stack. To initialize the stack, we have to make top as -1. Now, why this expression top -1? Because we have to assign some value to the top to indicate that my stack is empty. If you will make it as 0, it means it will indicate to the first position of the array, and as I told you that first position means 0 index and that contains the first element of the stack, and if it is empty you cannot make it as 0. So, we have to keep it one position, just subtract 1, that makes -1. So, top assigned as -1, whenever you read this value it means I am talking about the empty stack, or you can announce there and then that my stack is empty. Now, here the condition is to check whether it is empty, it should be less than 0. So, that is less than 0, that is why I say it is empty stack condition. For full, you have to compare it with maximum stack size -1. Why -1? Because my array starts from 0, my stack starts from 0 and 0 to 99, these are the total valid locations which can be used for the stack. So, in all we have got 100 locations. So, this is full stack. Yes, if it is greater than this, then it is full. Let us talk about the very first operation now, that is the push operation. Push int top, that is the indicator, that is the index that will keep track of the topmost element, and the exact element that you want to add, that you want to push. So, these are the two arguments given over here, and now my purpose is to add an element to the global stack which has been already declared globally. So, let us find some statements over here, as we have gone through that whenever you want to make a push operation, I must check whether the stack is full or not. So, the condition is very simple, find out this top, this pointer, is this greater than my maximum stack size -1? If it is, it means stack is full, return, we cannot push the element on the stack. But if it happens to be anything less than that, it means there is some slot, there are more than one slots or at least one slot, and I can add the element, I can push the element. So, for that you pick the item that has been picked over here, you can assign this item and the top can be incremented first, and then after incrementing the top, this item can be assigned to the array location stack top. Now, mind it here, this top has been incremented. If earlier its value was 4, it was incremented to 5 and item has been assigned to stack 5, that is the next array location. So, my task, that is to push a element, that is over. This function completes the job. Look at the pop operation similarly. Pop is very simple, to just talk with the statements to get the element out of the stack, take the element and decrement the top. Now, that is what has been done over here. You can look at element, pop and pass that pointer, pass that topmost value, that is the element you are interested to pop, and this is the only element that will be returned to you, because you cannot look into the stack and go to any element beyond top position and get that element after the pop operation. So, it has to be the top position, and just before popping we can check it whether this is equal to -1 or not. Now, this condition was to find whether this is empty or not. If it is equal to -1, it means either we have just initialized the stack or we have already popped the elements, that is why it has taken the value as -1. If it is, then return that stack is empty. You can generate the error, you can pass the message, ask the user to try and push some elements and then go for the pop operation. But if there are some elements this fails, then you straight away go to return stack top minus minus. So, this is first you get the stack top, you return this value, and then this is decremented. So, you might have done in your C++ or C language or whatsoever language you have done the pre-incrementer and post-incrementer. So, important implementation is application is over here, that if you write this minus minus afterwards, this is the post decrementer. The value will be assigned, returned, and then the top will be decremented. So, we have done with the pop operation. So, push and pop are the two basic operations, and we have done both the functions. You can analyze the algorithm whenever you read the data structures. We are always revolving around the space complexities, time complexities, how to make the algorithm better, and whenever you discuss the algorithm, whenever you write your own algorithms, we try to find out, analyze it and find that what time it takes, how much space it takes. So, that is just above the scope of this syllabus that we can discuss in the design and analysis of algorithms. And here we will see that push, pop, empty and is full. So, they are all going to take some time, because you have to add some element, it is going to take some time, you have to write some expression. If you write a loop for it, if you perform some nesting over there, if you compare the elements one by one, the time complexity will always change. So, that can be, the algorithm can be analyzed. But now, we come to the straight away to the application of stacks, and a very good application, that is the conversion of infix expression to the postfix form. Infix form, what is infix form? Infix is the way we are going to write the expressions as we do in the maths. Like if you want to add two numbers, I will simply write a plus b. It means operator is within the two operands a and b. So, it is infix form. Postfix, that you might have read, postfix is that if you specify the operator after the operands, if I write the same expression a plus b as a b plus, that becomes a postfix form. The postfix form does not need any brackets. Whatever the priority of the operators is in the infix form, that is absorbed in the postfix form, and this is done with the help of stack. How to convert it manually, you might have gone through. I will straight away come to the algorithm and explain you that what is done when the conversion of infix form to the postfix form is done. So, infix form contains some brackets also, it may not. Postfix is free of all the brackets, you will find only operators and operands, and it can be straight away calculated, evaluated by the machine, and to do this stack plays an important role. Let us look at the algorithm and scan the infix expression given to you from left to right. Whatever the expression is given, you read it from left to right, that is the very first symbol on the left, you have to read it first and then move to the right symbols. Now, if the character x is a operand, my dear, you can have only 3-4 cases, like I can have brackets, it can be a starting bracket, it can be a closing bracket, I can have a operand like a, you can have a operator like plus, minus, divide, multiply. So, these are the different symbols that you will come across whenever you read a infix expression. So, let us discuss these cases one by one, that if x is a operand like a I have told you, then output the character into the postfix expression. Simply pick this element, that is operand, and output this character to the postfix form. You are building a postfix expression. So, whatever the output list you are going to generate, you pick that element and straight away place over there at position 1. That is, your job is done for at least the one symbol that was a operand. And if the character happens to be, that is x, that is the incoming symbol, is a left or right parenthesis, then what you need to do? If it is a left parenthesis, push it onto the stack. There is a stack and you push this symbol on the stack, and if it is a closing bracket, then repeatedly pop and output all the operators, that is any characters, until starting is popped from the stack. Now, I repeat this one, that if this starting bracket is there, you can straight away push the element on the stack, and if the incoming operator happens to be closing bracket, then whatever the elements are there already in the stack, you start popping these elements until you get the starting bracket on the stack, on the top of the stack. So, if there are two symbols, I will pop those symbols, and then third symbol is a starting bracket, you will immediately pop this also and discard both the brackets. So, this is an important rule whenever you get a closing bracket. And if it is a regular operator like plus, minus, multiply sign, then what we need to do is, the first step is check the character y currently at the top of the stack. First of all, now you have to compare, x is the incoming operator and y is the symbol that is on the top of the stack. If stack is empty, second case can be that we have to compare, if the stack is empty or y is equal to starting bracket, or y is an operator of lower priority than x, then push x on stack. If we find that the top of the stack, now we were going to compare this, and if you find in the comparison that it happens to be a starting bracket or anything which is of low priority, then simply push this element that you have just read, that is x, on the stack. Step 3, if y is an operator of higher priority or equal precedence than x, that is the incoming operator, then pop and output y and push x on the stack. So, what happens in these three steps, that if my incoming operator is of higher priority, then something else is done. If it is of low priority, then something else is done. Now, look at the step 3 again, that if y is an operator, now I am talking about the symbol at the top of the stack. If this is of higher priority or equal precedence, then x is incoming operator, then pop and output y. Whatever was on the stack, you have to pop it and then push x on the stack. So, y will go to the output list and x will go to the top of the stack, and this will continue. Now, these are the different cases that we have discussed. So, you continue in the same way when all characters in infix expression are processed repeatedly, pop the characters from the stack and output them until the stack is empty. If you find that now the input has been exhausted, then you simply go to the stack and pop all the elements from the stack and place it on the output list. Now, whatever you get the output, that will be the postfix form. So, whatever the priority was here, that we have absorbed in the postfix form. Now, you have seen here that how stack plays an important role. Stack will always take care of which element was added and which is to be popped, because we are going to compare it. We are always concerned about the last element pushed on the stack, and that is the best given by a stack. Let us take an example to make this algorithm very clear to you, and I think after going through this problem, this example, every one of you will be very much aware of how the infix to postfix conversion is done, what is the role of stack, and how this expression is changed to postfix. Now, this is a stack, we have already declared it, we have got some fixed memory locations and a simple size is taken. This is a expression which contains some brackets, some operators, operands. We have got the postfix expression which is empty and we are just to start it now. Now, as per my algorithm that we have discussed now, we will start from left to right for a infix expression. Now, which is the first symbol over here, this is the starting bracket and you have to get this starting bracket and find out the rule that we have discussed in the last slides. Starting bracket was that if it happens to be this symbol, then you need to push it on the stack and we will put this symbol on the stack straight away. So, it goes on the stack, it is fine. Now, this is a operand and for anything x to be operand, you have to put it as it is on the postfix expression. So, partially I am building the postfix expression. So, this is the intermediate form of your postfix form. So, in next step you will find A will go to the postfix expression. Next is plus, this is the operator, we should compare it with the top and it happens to be the starting bracket and we have seen the rule that if it is a starting bracket then you need not to do anything, you push this operator on the stack and this is done like this. So, in this slide you will find that plus goes on the top of the stack. We have two elements in the stack, we have one element in the postfix expression and the pointer is moving from one position to the other position in the infix form. B as done for A, it will go to output list, that is the postfix expression. Talking about minus now, this need to be compared with, because this is an operator, compare it with the topmost and here we have got another operator. Now, you need to compare the priority plus and minus and you will find that after the comparison you will find this equal priority operator will be popped first, put it on the output list and then the new operator that will take the next position or the position on the top position on the stack. Comparison of operators, if it is of greater or equal priority, pop it, place it on the output list and get the incoming operator on the stack. We have the next symbol as C, C is a operand, it goes to the output list. Closing bracket, important case over here now. Closing bracket means we will look at the stack and pop all the elements from the stack till you get the starting bracket. So, here luckily we have got only one symbol. So, we will pop this symbol, placed on the output list and discarded both the brackets, the closing here and the starting here, both the brackets have been discarded and all the operators or the symbols which were over here, that has been placed on the output list, but here in this case we were having only one symbol and we have done with this. Next is multiply sign, stack is empty, it will straight away go to the top. D, operand, put it on the output list. Minus, of course need to compare. Comparison says that the top of the, that is symbol Y, has great priority, more priority than the minus over here. So, it need to be popped and then this will go to the top of the stack. Popped goes to this list and the negative goes, minus goes over here. So, I think you must be getting now that how that algorithm that we have discussed now has been implemented and we are able to convert this infix to postfix form. Starting bracket, it becomes simple for you now, it goes on the top, E should be over here, done, plus definitely it is a closing starting bracket, it will go top of the position and then F goes over here, closing bracket. Same case, you have to pop all the symbols till you get the starting bracket.